Welcome to part 1 of Competency 7. In this competency, teachers understand polynomials, rationals, radicals, absolute value, and piecewise functions, analyzes their algebraic and graphic properties, and uses them to model and solve problems. This competency is still part of Domain 2. In this video, we will answer questions relating to properties of functions. Number 1, what is the range of the function f of x equals 5, x minus 2 to the second power plus 1? Okay, for this particular question, you might quickly be able to see what values of y we're talking about range. We look at the values of y that are used in the function. What do I mean? Well, you can just put this in y equals. So I have 5, and I will type over this real quick. So we have minus 2, second power. Okay, when you type over, never mind, I just got rid of it all. So let's just retype. I was going to say, when you're typing over something, be careful. So, but I'm not doing that anyway. Notice I'm typing it in exactly as we see it, and I can use my x squared and plus 1. Now, let's graph this. Okay, we can kind of judge that maybe we're using 1 up. Remember, you're looking at the y-axis. So everything along the y-axis is included. Okay, and I'm looking at probably 1 to infinity. Okay, so let's look at our options. Well, first off, if we're looking at the y-axis, we have this whole everything underneath. None of this is used, none of those values. So we can't say all the real numbers relating to the y-axis. It's definitely isn't all of them. Now, another thing, word of caution, okay? I can see from this here, x equals 2, okay? So that's related to the y. Cannot use anything related to 2. That would be D, all real numbers greater than or equal to 2. We are not measuring against the value of 2, okay? So if this is 2, let's say we made this 0. If that's 0, then y would be 1. Okay, so how do we know this? Well, just go to your table. So if we go here and we say, let me look, is that, okay. First off, we need 2 and 1, okay? So second graph, I was just making sure. Yes, 2 and 1, okay. So here's 2 and here's 1. Okay, we know that we need to measure with 1. Okay, here's the issue. A says all real numbers less than 1. No, it would have been everything above 1. Now, the key thing for C, option C, that honestly makes it correct is it says all real numbers greater than or equal to 1. Your line, your curve, has to include 1. Let's go back to the graph. You'd have a gap at that minimum vertex, and you don't. It is equal to. We looked at the table, and this is true. So the option is C. Same thing with 2. So let's just do 2, and we can visualize what that is. And I can already see that we cannot include anything where x is equal to -4. So that would be B. B says all real numbers less than -4. Anything measuring, comparing with -4. Well, that's not correct. Okay, so let's go ahead and put it in. Some things you can see right away. Sometimes you can't see it. It's a little confusing. So let's see here. We have negative. Notice that I just typed in this negative there. Okay. Oh my gosh. Well, I say that. Let's go back to parentheses. There we go. I use negative. Be careful. Don't use subtraction. You will get an error. It just won't work. Okay, so that's our negative. Then x plus 4. Ah, see, be careful typing over. Okay, it's so easy to make a mistake. Double check. Don't just type in and then go to the next thing. Okay, so double check. Minus 4x, minus x plus 4 squared, and then plus 10. Okay, we're fine. All right, now let's graph it. Yes, everything below 10, but we have to include 10. If we don't include 10, that means our maximum here, our top vertex, our maximum would have like a hole in it. Well, it doesn't. How do you know that? You go to second graph, and then you go over to your x value, -4, which is here. If it includes 10, and it does, it says 10, then we're fine. It has to equal it. So it's A, all real numbers less than or equal to 10. And C is incorrect because look, it says greater than. Obviously, our curve is going down, so it's everything below. So we can't include that one anyway. Okay, all right, so let's look at number 3. Okay, it says a polynomial function of degree 5 has at least one complex 0. What is the maximum number of distinct zeros for this function? Okay, this is a trick question. Complex numbers have to come in pairs. So if you have 1, this means you have 2. So we have to have 2 complex. That's supposed to be a bold C. Okay, 2 complex values. All right, so it says we have a total of 5. So we have to have 3 out of the reals plus 2 complex, and that will give us our 5. So reals, that would be called the real distinct. So the maximum we can have is 3. Okay, so that has to be A. Now, we could have another combination. Another valid combination would be 1 real plus 4 complex. Okay, because complex zeros come in pairs, so that has to be 2, 4, 6, 8, and so on. So you just count them by twos, and then whatever is left over, and it also depends on your question, obviously. But for this question, they didn't give us, they didn't ask for 2 pairs of complex. They simply said 1. Now, if we have 1, we have 2. But if we have 3, we would have this situation. But we don't, okay? This is what we have. All right, so this is correct. All right, let's go to number 4. Number 4, a polynomial function of 6 degree has 5 real zeros. What is the maximum number of complex zeros for this function? Well, the first thing, if you remember, we just talked about it. All complex zeros must come in pairs. Our options are 0, meaning no complex and all real. So it's got to be 0, 2, 4, 6, 8, and so on. This means that option A is not valid for complex zeros, and C is not valid. That leaves us 2. Now we have 6 degree. So if we have 5 real zeros, and then we need 1 more to equal 6, this has to be real because complex zeros must come in pairs. So this can't, it has to be real. It cannot be complex. That would not be valid. So the only option we have left is D, and B can't be it. The minute they said five distinct real, we ran out of options. Okay, so let's look at number 5. The function h of x is a fourth degree polynomial with distinct zeros u and r. If each of these is a double zero, write an expression for h of x. That's the key, double zero. Okay? That means you have to have each situation in parentheses must be squared. And that means you have 2 plus another 2 equals 4. Okay? Okay, let's look at A. Well, this is to the first power. Well, 2 plus 1 is 3. It says fourth degree. That means you add your exponents up and it has to equal 4. That's not going to work. So let's look at number 5. That isn't going to work because all they gave us was R. And it says each of these is a double zero. So we know we're going to have it two doubles, 2 parentheses each being squared. And what happened to our Q? We have to have Q and R. So this isn't valid. Let's look at C. Well, we have kind of the same situation as A. That's to the first power because there's only one of them. So we have 1 plus 2 is 3. That is not valid. Now let's look at D. Regardless of the fact that we have this 5 out here, you can have whatever number factored out in the front. That's just something you're going to factor in when you're done, uh, you know, when you're done expanding this. It doesn't matter. What we need to look at is the parentheses. Well, we have Q, we have R, and our exponents 2 plus 2 equals 4. That means we have fourth degree. D is the only option that we can have. Okay, it is correct. All right, number 6. The function f of x is a third degree polynomial with a real zero. Yeah, a real zero. Okay, oh goodness gracious, a real zero called t. So that's kind of like what we had going on in number 5. Okay, and a complex zero of a plus bi. Write an expression for f of x. Okay, here's the thing. Complex zeros come in pairs, and the pairs are conjugates. The minute they tell you you have a complex of a plus bi, you have to have 2, and they're conjugates. This means that you have a minus bi also. Must have, doesn't matter if you don't have that, it is invalid. At least that has to be there. Now, you also have an x minus t or plus t, one or the other. You got something going on with x and t to be a real zero, whatever. Okay, here's the thing. Look to make sure you have your conjugates first. This is not a conjugate, that can't work. This is not a conjugate, that can't work. Now I see my a plus bi. Here's my conjugate, a minus bi. And I have a distinct real zero of t because that would be x equals t. Okay? So I'm thinking C is good. But D, nope, that's not going to work. This is not a conjugate, not, it will not satisfy the situation. So it has to be C. Okay, this is the last question in this in this first part of Competency 7. And once again, thank you for watching and liking certain videos. I've seen a lot of liking and sharing on the channel. And once again, if you haven't subscribed and you've been enjoying our videos, I thank you for watching and I thank you for subscribing. If you haven't subscribed, please think about it and happy testing.